This is the homework for lesson number 82 of the Arduino Uno R4 Wi-Fi. Paul asked us to use the gyros to come up with roll, pitch, and yaw. And here's what I've done. Let me go to the software first. You can see here is typical include stuff. I added a GX, GY, and GZ. I added a T loop and a T start. And then I set up variables for roll G, roll A, roll comp, and pitch comp, and yaw. Those are the variables that were added. Okay, we got down here I did a T start equals millis. Millis is like, I forget what he called it, was some time start somewhere. Anyhow, it starts to count. Then we go down here. Then we set the gyros up earlier in the lesson. And then we go down here. And I've got the offset and all that stuff on the accelerometer. Okay, then of course here's where we calculate the pitch in a row with the accelerometer. And then we put it through a low pass filter. Now, come down here. After we do all that, I set a T loop equals the millis now minus T start from earlier divided by 1,000, because I believe that's in milliseconds. We got to get it into seconds. And then there's T start. We reset the T start. Come down here. This is where we get the roll G. We take the roll G and a GY, which is up here. GY is this guy, okay, where you get the information from the gyro. Okay, and GY times the T loop. T loop is that interval here. That gives you the roll for the gyro. And then the same thing for pitch. Your GX and the loop and pitch G. This is the pitch G, this one, plus that one. Okay, now we got here. What I've done is, because you have it starts to track right off the screen if you don't do something. So I've got I compensate it by tying it to the accelerometer by 10% and the roll comp by 99%. He says, hey, roll comp plus the GY times the T loop. That ties that roll together to the roll GA, which is pretty solid. This guy just tracks off the screen. So to keep it from doing that, we tie it together with this. I'm going to do the same thing for the pitch. Down here, I've got the yaw. It's also tracking off the screen, but I'm not sure how to stop it. I figured out how to stop these, but I don't know what to do about that one. Anyhow, if you look here, then we print everything. I print the roll comp, pitch comp, then the yaw, and I put the yaw. And then we got the limits. Now, if we go down here, let's go ahead and run it. We're already running. Let me reset it. Reset. The yaw will go to 0 degrees. Maybe. Try it again. Boy, it's really tracking off fast. It wasn't doing that earlier. these guys work. Oh no, this thing quit working. Hang on. Let me unplug the pokey. Some reason this thing does get into kind of a weird position where everything doesn't want to work. Now the roll, pitch, and all that stuff is working. Now if I reset it, you can look at the yaw. Look at the yaw. I go to 0. Okay, now if I go this way, it's positive 45 degrees. Go that way, it's minus 45 degrees. And it's already starting to drift off. Now here's a pitch. This is a positive pitch to 90. Then we have a negative pitch. Let's get off the screen here. Here's negative pitch. And then positive roll, 90. And negative roll of 90. Anyhow, there we go. In order to get my pitch back, I'll have to reset it. Now pitch is back to 0 degrees, and this now relates to degrees as you turn it. You can turn it all the way around if you want. Darn cable gets in the way. There's around 360, but by now it's already started to drift off. So put it back. We're off by 13 degrees already. Anyhow, there's my homework, and I'm happy that you do these videos, Paul, and I look forward to next Tuesday. Bye.